today we're going to do problem number 11. Identify the graph of g of x equals 5 times the quantity x plus 1 times the quantity x plus 2. Label the vertex, the axis of symmetry, and the x-intercepts. Then they want us to describe the domain and the range of the function. I'm going to start out by trying to find the x-intercepts. Now when I look at this function, I can see that there are parentheses, but the parentheses are not squared. So this function is in intercept form. And I'm going to write the function down, and I'm not going to write it as a function. I'm going to write it as an equation with a y. So it will be y equals 5 times x plus 1 times x plus 2. When we're looking for the x-intercepts, we're trying to find the x values when the y values are 0. So I'm going to rewrite my equation like this. And if I can find the solutions to this equation, I will find the x-intercepts. So I know that this doesn't have a coefficient and this doesn't have a coefficient, so my solutions will just be the opposites. So I get x equals -1 and x equals -2. So my x-intercepts are -1 and -2. The next thing I'm going to do is I'm going to look for the axis of symmetry. To find the axis of symmetry, which is the same thing as the x-coordinate of the vertex, I'm going to use this formula. X equals p plus q divided by 2, where p and q are the x-intercepts. So this turns into -1 plus -2 divided by 2, and that'll give me an x-coordinate of -3 over 2. So my axis of symmetry is x equals -3 over 2. Now, to find my vertex, I already know that my x-coordinate is -3 over 2. I just need to find the y-coordinate of the vertex. So I'm going to go back to my equation where I wrote it with an y instead of in function notation. And I'm going to have y equals 5 times x plus 1 times x plus 2. And now I know that my x value is -3 over 2. So I'm going to write y equals 5 times -3 over 2 plus 1 times -3 over 2 plus 2. So I have y equals 5 times this first set of parentheses. If this is really -1.5 and this is +1, then when I put those together, I will have -1/2. And if this is -1.5 and this is +2, when I put those together, that will be +1/2. So my y-coordinate of my vertex will be 5 times -1/2 times +1/2. So if you do that on a calculator, or if you can do it in your head, that will come out to -5 over 4. So the y-coordinate of my vertex is -5 over 4. So I have the x-intercepts, I have the axis of symmetry, and I have the vertex. Now I'm going to make the graph. I'm going to start by putting my x-intercepts on. So one x-intercept is at -1, and one x-intercept is at -2. My axis of symmetry is going to go right in between those 2 points. So my axis of symmetry will look like this. Now to finish putting my vertex on the graph, this is 1.5 to the left. That's the same as -3 over 2. Now I need to go down 5 over 4. That is the same as 1.25, or 1 1/4. So I'm going to go down 1 and then a tiny bit more. 1/2 is here, probably right here. So there's my vertex. And so now if I can draw a smooth curve through there, that will be my parabola. So that's what my graph is going to look like. And just to make it easier for us, my vertex is at -3 over 2, comma, -5 over 4. So the last thing we have to do is find the domain and the range of our parabola. So the domain will be all real numbers. And our range, if we look at our graph opens up. And our y-coordinate, our vertex, is -5/4. So every point on our parabola will have a y-coordinate that's greater than -5/4. So we would write it like this. Y is greater than or equal to -5/4. As you can see, the two graphs on the right have the correct axis of symmetry. And both graphs on the right have the correct x-intercepts labeled. The difference is the vertex. And the one that has the vertex that matches the one that we calculated is the top right graph. So the correct answer on this problem would be to pick the top right graph, and then you'll have to fill in the domain and range, and you'll have number 11 done correctly.